Okay, you're going to kind of see the things on the right hand side. Those are my charges again. You know, the ones that are circled are the ones in the red regions, except for the hydrogen, which is usually a +1. These two, those are usually standard ones for those. Okay, so we're going to go with redox. I'm just going to put them in the forms of reactions. There are going to be some little terms that I'm going to be adding to this. So let's say we have a reaction that kind of looks like this. Okay, so this is my standard reaction for this. Now we're going to go ahead and we're going to do some different classifications on this. First of all, we are dealing with something called a redox reaction. They occur on pretty much every single reaction with the exception of double replacements. We have to assign charges on each one. Now on the previous one, that's going to be an advanced one. For the regulars, you have to remember when everything is by itself, these are going to be neutral because we don't have a charge next to it. We do know that the charges of these are going to be based on where they are on the periodic table. We know that Na is a +1 and we know the chlorine is a -1. So you have to kind of look at your charges for something called redox. Sometimes they're given to you, sometimes they're not. So what we have to do is compare. So we call these guys half reactions because we're just going to take the parts that are the same as each other. So we're going to look at things that look like this. Now just remember, I don't have to take the 2's here, I do have to take the 2 here. So we got an Na with a +1 charge. We're not going to balance these. So if you're in advanced, it's not going to be correct completely because we're just going ahead and doing the standard stuff. We have an Na with a +1 and we have an Na with a 0. That's going to be my first part of the half reaction. My other one is actually going to go in the opposite direction, and that's going to change our classifications. We're going to put a 2 here. Again, it's not going to be a balanced one. That's going to be for the advanced. We are just going to go ahead and classify because that's what we have to do for the regular students. So let's go ahead and erase this part over here. I don't think we really need to be looking at this right now anyway. So we have this one here. Now what you have to do is you have to compare what you're doing from here to here. So you're going to look for the one that's actually the numbers getting smaller or being reduced. We call this reduced. Oops. Which is also referred to as reduction. These are going to be the same terms. Which would mean that my other one, reduced, is going to have an OX there, and this one is called oxidized. Or it's also referred to as oxidation. Now that is the first part. And then we can also do a little reversal as far as using these two terms. This is called an oxidizing agent. And this is going to be called a reducing agent. So you're just going to have to remember you're doing in reverse. So if you have a question that says, well, I have something that is an oxidizing agent, and what is the one that's the oxidizing agent? You have to find the one that's being reduced. So you're just going to have to kind of remember these are opposites. Let's go ahead and do another one. Again, we're just going to stay with the standard redox. Let's say I have one that looks like this. It'll look a little bit different. So let me get this all written out. Let's see. And then let's say I got another one that looks like this. So I got to just make sure I'm doing things correctly, because we don't want to get confused. Let's say I have something that kind of looks like this. Again, we can do our half reactions, but in this case, we really don't have to. All we have to do is kind of identify which one is actually being reduced on here. We're going to go with the same elements here, and we're going to notice that this one actually, the charge reduced. So this one, Mn, is being reduced, so you can easily tell it looking at this. And then on this one, the charge went up, so we know it's not reduced. So we're going to call this oxidized. And remember, this goes through reduction, this one goes through oxidation. Pretty simple. This one's going to be my oxidizing agent, and this one's called my reducing agent. I just go according to OA and RA. Okay, so some of them are going to be actually pretty easy to figure out what's going on. Let's go ahead and do another one. Again, I'm going to do like 3 or 4. Let's say we have one that looks like this. Let's go Ca plus O2 yields CaO. So we have this. Again, we can split it up. We can write the charges. We can do half reactions. But in this case, again, regulars, we want to go a little simpler. So we're going to go, we know that's a +2. We know that's a -2. We know that when it's by itself, it's going to be a 0. This one's kind of simple to see which one got smaller. Well, this one went up, this one goes down. We know that this one and this one are actually reduced. So O2 going to O, O2 is going to be reduced, or underwent reduction. We don't want to look at the end result. It's always the first one. So a little bit added thing to it. And then, if I want to do my other one, I'm going to notice that the charge went up. So my Ca going to Ca +2 is actually being oxidized. So this one's called the oxidizing agent. I'll just go ox A, and this is red A. Now let's add a little bit to this. We refer to this whole thing as Leo goes Ger. And then there's a different one or a different slogan, but I go with Leo goes Ger. So we see this part here. So this one here actually gained electrons. and this one here lost electrons. So again, we're kind of going into ionic type of things where we have ones that are gaining and ones that are losing. And we always have one of both. So again, a little more detail, but again, it's not that difficult. Let's go ahead and do one more. Let's go, and sometimes it's hard to pull it up, but let's go, I'm trying to stay with this easy stuff, but sometimes we can't avoid it. So we're going to go Al plus CuO. We'll just go ahead and put different charges here. This is called a single replacement. Now, as far as the balancing, we'll just put our balancing numbers here so it all looks correct. And then what we're going to do next is we are actually going to do our redox. Now, if you remember, the easy one to figure out as far as my charges is going to be the oxygen with a -2 charge. And your -2 is coming from this one here. Since we already have numbers here, we can do that. The copper, we're going to do our same standard thing, and we know that's going to be a +3 because we have to make sure it's neutral. And then we also know that this one is here. The ones that are by itself, we're going to go with 0. Now we only look at the ones that actually go through change as far as charge. Since our oxygens are always going to be a -2 charge, we don't have to worry about that. We can classify the oxygen, we call that a spectator ion because it doesn't change. It's just there, it's watching the action, and we also refer to that as a placeholder. Now we can look at our charges here. Again, it's kind of getting a little bit of detail here, but I'll put a box around it. We notice that the charge here actually went down or reduced. So Cu is reduced, which will make it the oxidizing agent. We know that this one is GR, so it gains electrons. Now we've taken care of the copper. Now we can do the aluminum. The aluminum went in the opposite direction. So now we're going to be dealing with that. And it's going to go from 0 to a +3, so it actually went up. So Al went up. We know that it's the opposite now, it's oxidized. We know that it's the opposite, reducing agent. If you kind of look underneath here, they're opposites. This is reduction, that's oxidation. And this one is Leo, that one's GR. So we can put GR here in Leo. This one loses electrons, and the other one gained electrons. So that is called the process of redox. Make sure to take a look at this. We will have some assignments on it.